activity I like to call candy decay. To start, you want to gather your materials. What you will need is a paper or plastic plate, 2 of them, a pen, a notebook, and candy, preferably with a label like M&M's or Skittles. So to start, you want to place your candy label side facing up, and this will represent our parent isotopes. Next, you want to get the paper plate, cover the parent isotopes, and give them a good shake. 1, 2, 3. So after this shake, we can see that about 9 have flipped over. And for the sake of this video, I started with 20 parent isotopes, but typically you would want to start with like 100. So here I will be taking away the 9 that have flipped over, and separating them and putting them off to the side. This is a decayed daughter product. So in our notebook, you would want to start with writing out the starting number of parent isotopes and the decayed daughter product and the number of half-lives, which should be 0, 20, and 0 for this project, well, this video. And then afterwards, we see that we have about 11 parent isotopes left, so that would come next, and we have 9 decayed daughter product, and this is 1 half-life. So if we do this one more time, we see that about 5 have flipped over, so we can take these out. 2, 3, 4, 5. Separate them, add them to the decayed daughter product, and now there's 14 decayed daughter product, and now there's only 6 of the original parent isotopes left, and that is 2 half-lives. So after completing our activity, we can see how it meets both our science standards and our objective. We created a model that helps illustrate half-life and radioactive decay. The brand side up candies represent the unstable parent isotopes, while the flipped candies, brand side down, represent the stable daughter isotopes. Stable isotopes are non-radioactive, have stable combinations of neutrons to protons, which is typically a ratio of 1 to 1.5 neutrons for every 1 proton, and do not undergo radioactive decay, so they don't emit radiation. Unstable isotopes, however, are radioactive and undergo radioactive decay, so they emit radiation and do not have a stable ratio of neutrons to protons. Since they are unstable, they undergo radioactive decay in order to become more stable, because this process helps change the ratio of neutrons to protons to a more stable combination that is closer to the band of stability. Radioactive isotopes take different times in order to decay and become stable, and the time when half of the radioactive nuclei in the sample decays is called half-life. The ratio of parent to daughter can help us determine half-life, because each time half the sample decays, this is 1 half-life. And using this method, we can determine how long ago something was, because we can count the number of half-lives and the time it took for about half of the radioactive nuclei to decay, allowing us to count and determine the time when an event occurred. Thank you so much for watching.